something that enterprises and businesses going to now, whereby you try to deliver a software that appeals to the end users, the consumers, that tackles the problems that they are facing. But at the same time, that's something that generates, let's say, your funds and your profits as well. So enterprise and businesses that make use of this method of service, which is the software SaaS, likes of Netflix, Uber, Dropbox, just to mention a few. All right, so as I said, SaaS is a way of delivering applications over the internet as a service. It's software-based and it's connected to the cloud computing. This helps in making the software easily accessible from anywhere, not just rather than just a limited network. So initially, SaaS started off as web-based softwares and on-demand softwares, or mostly hosted softwares that are placed in, let's say, different locations. Some certain softwares around some certain environments where you can't have access to them, maybe outside the country or the state or something like that. So that was how it started off as. Then until the cloud computing came into play very well, mobile application became more rampant. So when they started as web-based softwares, it was a good idea in the sense that it was able to eliminate installation problems, and so it was easy for users to actually have access to it. As a how Facebook started as a web app or as a website like that. So it was easy for people to actually have access to it, where they could just go online and click on it. But over time, we realized that it began to have some limitations, because things like mobile application now, since everyone uses gadgets, phones, laptops as well, it's become much better to actually have mobile applications, in the sense that mobile applications get to use the resources of the device that you're holding, compared to web applications that are just they get updated over time online. So that is not, does not have effect, it does not have any effect on the system that you're on, the phone or the device you're using, compared to mobile applications. And then mobile applications became secure, and over time, the rise of SaaS mobile applications began to rise. So softwares that enterprises use to manage their businesses, work effectively, maintain better service delivery, and achieve customer certification. Majority of these softwares now are mobile applications. The reason is because they give the best user experience, and there is a need to capitalize highly on this so as to achieve the best possible outcome. This also gives users flexibility and access to whatever they need whenever they need it now. Now, for example, let's use Uber. Uber could not have been better. The decision they made as mobile applications compared to being a web app, because if you're using Uber currently, it uses your location on the device of your phone to access where you are, to access how far off you are, how many kilometers you are from the destination or from the driver. This is something that has been very helpful. So it has become really wise that mobile applications are the venture to go into while trying to develop a SaaS startup. So now, as a SaaS startup, what you should worry about the most is how to create the best user experience for your customers. Because you should do this while also trying to provide the service that they need as well. So in order to develop a SaaS software, you would want to target a specific market, consumers, age group, solve a problem, offer a service, appeal to people who will need to undergo series of planning, we should take weeks and even months. So yes, you don't want to rush things because when you are trying to develop something that is going to be the way forward, going to solve a problem, you have to actually take your time to plan. It is important to actually take time to plan and just rush into things. Because if you, if assuming now you start up and you fail to meet up to a certain, you know, let's say a certain bit of what's it called? Let's say performance now. If performance is an issue, it becomes if performance is an issue, it becomes a problem because you don't want that. So you need the right team as well, because if you're trying to develop a SaaS, you need the right team who can make it come alive. Okay. So first of all, you want to know how this sort of project is initiated in the first place. Now, how is this kind of project initiated in the first place? The project initiated as a result of observing the need, the demand, the opportunity, and problem, and coming up with strategic steps to work within those given spaces and loopholes so that your product solution provider provides to people's needs, satisfies consumers, and fills a missing gap in the market while tackling problems as well. So important criteria you should look at before you now begin the project is that you need to understand why there is a need for the project, why there are funds. No, you need to understand, you need to get the right funding available, and you need a strong way to make sure that the project will succeed, as well as the right team. So the needs and demands represent opportunities, business requirements, problems needed to be solved. A project comes about at least one of the 7 needs and demands, which are the market demand, the strategic opportunity and business needs, the customer request, technological advancement. Like now when banks, you know how banks now started trying to go into mobile application rather than using the USSD code because that is the right thing to do. People are using more of Android and iOS phones, so it's best to actually develop software at this time to appeal to those people rather than just use the normal USSD code, which is still fine, but it's better to make things change as time goes on. So legal requirements, ecological impact, and the social need. So now you'll be wondering what the role of a project manager is in all of this. Well, as we know, the project manager is one who is responsible for the planning, organizing, mapping out contingencies, directing the completion of a specific project for an organization, while ensuring this project able to meet the requirements, satisfy consumers, and also that's why putting in account the time, budget, and scope given. So as a project manager, you need to also know the team, the right team with the right skill set you should hire, because it's important that every single aspect of how this software will be executed is going to be given as much focus. So the project manager working for a SaaS company emphasizes their strength on the use of softwares to address the consumer's needs. He has to arrive at certain decisions to work with in this aspect. Ah, Jesus. Hello, can you hear me now, please? Hello.
Yeah, I can hear you. I can hear you.
Please, where did I stop? Where did you stop hearing me?
I was not even getting you at all.
Wow, so I
I
have to
thought
start.
it's from my
It's not that we are not hearing that you are saying something, but you are just doing well. You understand?
Okay. Okay, let me start again. The SaaS delivers software as a means of service. Now, examples of SaaS, as you would know, are like are the likes of Netflix and Uber or Dropbox. These days now, businesses and enterprises have been going into the use of SaaS to deliver a software for the service that they render because it has become much more better to do. Now, as a software service-based company, which is SaaS, the way of delivering applications is now over the internet. SaaS is software-based and is connected to cloud computing. This helps the software to be easily accessible from anywhere rather than a limited network. So initially, SaaS started off as web-based softwares, but because web-based softwares are not web-based softwares are very limited. They do not have access to the resources of the device that users are using. In the sense that now, if like Uber, how Uber did it with the mobile applications, where it's much better. The mobile applications, whereby if you when you request a ride, the driver can look at your location and you can see how far you are away from a destination, and it can map out the best certain route, the best route to take, where there's huge traffic, where there is not as well. So the location on the device that you're using cannot be accessed because with the use of web applications. Now, that's why it has become the best idea to use mobile applications to deliver your service. So as of today, mobile applications have been on the rise for SaaS enterprises and businesses, and mobile applications are very safe and secured. So it has been a huge blessing to the SaaS. Now, softwares that enterprise use to manage their businesses work effectively, maintain better service delivery, and achieve customer satisfactions. Majority of these softwares now are mobile applications. The reason is because it gives the best user experience, and there is the need to capitalize highly on this so as to achieve the best possible output. This gives users greater flexibility and access to whatever they need, and whenever they need it. So now, what should be the focus on a SaaS company is how to create the best user experience for their customers. They should do this while continuing to provide them the options that meet their needs. A user experience is what makes or break a SaaS product, because if you make a very good product but you are not appealing to the users, it is a problem. You need to appeal to the users while also delivering the service that you have defined to deliver. So in order to develop a SaaS software, you would want to target a specific market, consumers, age group, solve a problem, offer a service, appeal to the people you would need to undergo. And you'd also need to undergo a series of planning, which could take weeks and even months. So to make this happen, you need to have the right team as well. So first of all, you want to know how this sort of project is initiated in the first place. Now, how is a project like this initiated in the first place? The project is initiated as a result of observing the need, the demand, the opportunity for the project, the problem, and coming up with strategic steps to work within those spaces and confinements, as well as the loopholes, so that your product provides and satisfies people's needs, customers, and fills the missing gap in the market while also tackling problems. So there are important criteria for projects like this. However, before you can start executing them, which are what is the need for this project? Are there funds available to finance the development of this project? And is there a strong will to make the project succeed? Especially, and do you have the right team? So what are the needs and demands? Needs and demands represent opportunities, the business requirements, problems needed to be solved. So a project comes about when one of the 7 needs or demands are met, at least one of them, which are the market demand, the strategic opportunity and business needs, the customer request that will be based on a customer's order. technological advancements, like how banks did it with going not really going away from the USSD code, but to the mobile application development now.
Hello, Mr. Ejide.
Hello.
Sorry for the interruption. You just have 2 minutes more.
Okay, so
all right.
With how banks did it with the technological advancements, where they are able to use mobile applications now, because most of their users are mobile app users as well, mobile device users as well. So what is the role of the project manager in all of this? A project manager, as we know, is one who is responsible for the planning, organizing, mapping out contingencies, right, directing the completion of a specific project to an organization, while ensuring the project is able to meet up to the requirements needed to satisfy the consumer's needs, despite putting in account the time, budget, and scope given. The project manager will need to gather the right team with the right skill sets. So the steps the project manager will take while playing this role, they will need to work on the documentation needed that addresses certain parameters in the project, which are, what is this project about? What are we doing? Why are we doing this project? What are the competitors we are likely to face during this project, and how have they done it better? What do we base our own strength on? The requirement analysis, the functional requirement, and the use case diagrams to show how actors influence the system and how certain decisions give certain kinds of responses. So project initiation, the project manager recognizes the need of a new project or the next phase of an existing project should begin, and starts the project by allocating all the required resources to be committed to this project. Now, these resources go from the cost needed, the team members, certain skills, and the services that are needed to work together to bring about this execution. So to get the team ready, the team will consist of the UI UX designer, a front-end developer, a back-end developer, a marketer, best to find one in both spaces, which is digital and physical space, lawyer, a business development manager. Now, the project manager has to demand excellence in delivery of the software, making sure that all sorts of loopholes that either won't appeal to the users are overly complicated, that won't appeal to the users, or things are overly complicated or has delayed response in time are all eliminated, thereby making performance, reliability of users on the platform user-friendly and simple to use all goals as well. So there are certain things that the people who are who are on the team would also do, such as the UI UX designer is the one who takes it from documentation stage into what is more represented, like what is more presentable. This is the first stage where it goes from just an idea to, to a certain confinement of images and how it should work and how this and this should be like, so that it can be it is interpreted to the front end and back end developers who are able to produce the software. The marketer markets the software, while we have the business development manager who in the team as well. These are the ones who are able to generate sales leads. They're able to create strategic alliance partnerships, like how Amazon did with DHL. When Amazon started with delivering their services, they needed to partnership with a dispatch company, which they did with DHL before. And this helped the business to work out well. So they also should find ways to generate referrals. It could be through word of mouth or other forms, really. And they create partnership patterns that the software platform will end so as to achieve profit goals, like the way Netflix did with subscriptions as well. So,
all right, Mr. Jide, thank you very much. Our time is up. We're constrained.
Okay.
So that the next speaker will come up.
All right. I don't know if people have any questions. So I can...
the question will be taken at the end of the second speaker.
Okay.
So please, if you have questions for Mr. Jide, you can please jot it down or just keep it for the question time after the second speaker. So you can stop sharing your screen. Thank you very much for addressing us today. So Mr. Semeton. Mr. Semeton, you can share your screen. Can you hear me, Mr. Semeton Balogun?
Yes, started sharing his screen.
All right.
I think we're good, right? Okay. So good morning, everyone. In the second presentation for today is database catching. So today we'll be looking at what a database is. We'll look at the three-tier architecture, look at what database catching, the types, the catching strategies, and also the benefits of database catching, basically. So we should be able to know all this at the end of the presentation. So essentially, databases are an integral aspect of software development because they help us to store user data precisely, and we can organize them, we can manage them as the case may be. However, to ensure for optimal of efficiency and optimal usability of applications, it is essential that most of the database that we use allow for low latency, and they are scalable. And what this literally means is that latency has to do with the timing of retrieving data or of saving data in the database. So we want to ensure that we want to do that within the shortest possible period, and then want to add as much as possible in terms of volume, and that's what scalability is all about. But there's a challenge with the disk-based databases that we mostly use, and the challenge is that they do not allow for low latency and scalability. So it is very expensive to scale, and it can actually be slow to work with data that is stored in them. And so catching is a way of circumventing this particular problem, and that's what we're looking at basically today. So let's just look at an overview of what a database is. So it is basically an organized connection of structured information or data, and is typically stored in a computer system. And this is actually part of the three-tier architecture, which I'm going to show us in a short period of time. And this database is usually controlled by what we call the DBMS. That's the database management system, which we commonly use oftentimes like MySQL, Microsoft Access, even relational database management system, RDBMS. And these are just basically where we manage this data and we store them precisely. So, and any data that is stored in the database can be queried. Yes.
Hello, Mr. Balogun.
Yes, sir.
Okay, you're still on first slide, please. Okay.
Oh, I'm moving it. I don't know. I'm moving it from here.
It's not moving.
Okay. I think I will share it. Okay, is it working this way now?
Yes, we're seeing the overview now.
Okay, awesome. So I said that any data that is stored in a database can be queried. That is, we can access it, we can manage it, we can modify, we can update, control. We can basically walk around with it. And that's the one importance of the database in itself without losing the data. So this is what a top 3 application looks like. So you have the three-tier architecture rather. So you have the presentation layer, the application layer, and the data layer. And what this basically means is this: whenever we are working with a software, let's say this Zoom call, for instance, what you can see is the presentation layer, the text, the shapes, the whole UI UX basically thing. So, and then the application itself is what works in the back end. Like you want to, for instance, let's say you are on a contact page, you want to input something, you want to click on submit. So what is going to make this thing work basically is the application. And the data we input, for instance, is going to be stored somewhere, and that is the database. And the database, like I mentioned earlier, is part of this, is the third part of this structure, this architecture. So now let's move forward and let's talk about what database catching is. So it is a buffering technique that stores frequently query data in a temporary memory called a cache, and this supplements the primary database. So what this basically means is this: just imagine a computer system that has a read-only memory and a random access memory. So when you're working, for the most part, your working memory with the RAM temporarily stores data, and then you can save them later into the read-only memory, which is the permanent memory. So what this does is that you don't want to relieve the main memory of unnecessary pressure. Now, the kind of data that are usually cached are the ones that are frequently queried. So if you need to retrieve the data often and often and often, or rewrite it often and often, you don't want to be going to your database in and out. I mean, given the time it might take you to do that. What you want to do is to temporarily store it somewhere where it is handy, and then you can use it for as many times as possible that you need that, basically. So this makes it easier. It makes it easier to access data, and then it relieves the workload on the main database in itself. And then this cache can reside in a number of areas. It can reside in the database, so it can be integrated into the database. It can reside within the application in itself, what we call a local cache. And then it can sometimes be in a dedicated server in a standalone layer, where you can just basically temporarily store the data and then retrieve it. And a typical example I can give here is a library. So in a library, you go there are shelves where you can basically pick up a book or the other, and then you want to read. But sometimes you want to read the book and then you want to go back to some other books. Instead of going back and forth into the shelf, you can just keep it somewhere where you are reading, and then you can reach out to it and use it, and then return it to your side. And then when you don't need it again, you can then put it back on the original shelf. So that way you don't have to waste your time going back and forth to the main shelf to pick the data. And that's exactly what database cache basically help us to. So these areas where a cache can live actually now give rise to the types of database cache that we basically have, which we are going to be looking at next. So we have the first step is the database integrated caches, and in this case the cache is integrated to and is managed within the database engine in itself. So the data cache is a separate layer within the database. And then an example is the Amazon Aurora. It has an integrated cache in itself that can temporarily store data that are frequently queried. So another type, the second type, is local caches, which reside in the application layer. So the cache is in the application that you're using, and for as long as you are still on the application or you are going through that particular session, you can easily temporarily store the data that you're frequently using or that you frequently want to manage or analyze, basically. So it removes the network traffic associated with retrieving data, making data retrieval faster than other caching architecture. So you don't actually have to go far to retrieve this data you want to use. It's just within the application you are using right there. And the last is the remote caches, and these are caches that are stored on dedicated servers and typically built upon key values NoSQL. An example is the Redis and the Memcache. So these are on standing layers, like I mentioned before, on dedicated server, and you can temporarily store the data there. So up next, we'll be talking about database, the caching strategies, top caching strategies. There are a number of them, but we'll look at a few. So the first is cache aside. So what cache aside basically is that the cache is residing like different on a layer different from the database. It is not connected to the database directly in any form. So this is what happens. Whenever a data is being queried from the application layer, the data is first accessed in the cache that is standing alone. And then if the data is present, that is what we call cache it. So if there's a cache it, the data is just retrieved back directly into the application layer. But if the data is not there, what is called cache miss, then what happens is that the application then will now go into the database, then retrieve the data, and then we now write it in the cache. So it's going to update the cache by writing the data there, so that when it needs it, there will be a cache it, and then it can easily retrieve it. But the cache in this case is not connected to the database at all. So the second one is read through. In this case, the cache is in between the application and the database layer, and it's connected to the database, such that when a data is queried from the application layer, we first of all get to the cache and then try to check if the cache is there. So if there's a cache it's just going to return it directly to the application zone. But if there's a cache miss, it's going to pass through the cache, go in directly into the database, and then as the data is being retrieved, it's going to be written first on the cache, and then we go back to the database, to the application where the user that requested for it is going to make use of it. So in this way, every data that is retrieved from the database is written on the cache, and then you can always access it whenever you want to query it next time. And then what we have next is write through. In this case, when an application writes the data, or when you input the data in an application, it is first of all written on the cache, and then immediately it is written in the database, such that when you want to retrieve it next, you can get it. So we need to underline the word immediately. Like in write through, any data that is written on the cache is directly written immediately into the database simultaneously at the same time. The next is what we call write back. So the write back and write through is any data that is written in the cache. It's not immediately written in the database, but it's written once in a while, occasionally, maybe every 2 minutes, every 5 minutes, as the case may be. But it's still going to be written eventually in the database. And then whenever it is requested, or you want to retrieve it, you can just retrieve it from the cache quickly, in solving the problem of low latency, and then you don't have to necessarily go to the database and then increase your time in retrieving the data. And then the last is write around. So write around make use of at least two. You're going to make use of one of the ones we've discussed, like catch aside or write around or read through rather. And then it's going to combine it with write around. So what happens is that, let's say if you're using the catch aside, so if there's a catch, you're going to retrieve it. If there's a catch, if there's a catch miss, you're going to go to the database and then retrieve it and then write it in the cache, like we mentioned before. And if it is a new data that is being written into the cache, and it's going to check if it's already in the database. If it is not there, then you're going to write it there. So it works both ways. So you check the cache and you check the database. So anyone that is missing, you want to write it in both of them, basically. Also, the other one here that is read through. So when you read a cache and then the data is present, you retrieve it. If it is not in the database, you want to write it into the database, because this can happen in the one I write for write back, because most times the data is not immediately written in the database, right? So you want to ensure that it is there. So if it's not there, you want to write it there immediately. And this is the last strategy that we'll be discussing in database catching here. So let's talk about the benefit. So the benefits of database catching, put it in 3 ways. So the first is performance. So database catching actually improve performance in terms of increasing the time of retrieving your data. So you can easily retrieve your data without going to your database as quickly as possible. And then it can allow for scalability. So you want to, scalability has to do with increasing the amount of data the database can take in, the volume basically. For instance, in the story we talked about in write back, the cache can actually serve as a supplementary database for the main database. So let's say there's some data that is only needed for a particular session, and they are not necessarily needed to be stored in a database. You don't need to increase the volume of data in your database by writing that data there. Remember, it's not necessarily stored there. So you can temporarily store it in your cache and use it for that session. And as long as the session is on, you use it continually since the cache is there. And if the session is over, everything is cleared. And that way the volume is retained in your database for other data that are essential to be stored there. And then the last is availability. The data in the cache that is stored in the cache is readily available. If the cache is residing in the less application layer, you can easily get it. If it's even a dedicated server too, it is there, it is readily available. There is no traffic, there's no network traffic, that maybe you have to wait the database, want to make your application is loading and loading and loading. No, it's just there. You can just retrieve it quickly as possible. So this way we are able to solve the problem of low latency and scalability, like I mentioned in the introduction. All right, in conclusion, a database cache is basically a temporary database which supplements the primary database. It's not taking the primary database away, it's supplementing it. And it helps us remove unnecessary pressure on it by helping us temporarily store frequently queried data. and that we can easily retrieve. So the cache, like I mentioned, can live in a number of areas, including the database. It can be integrated into the database. It can live within the application layer, and can be it can live and can reside in its standalone layer, like dedicated server. And it is an essential and effective strategy in improving the overall performance of the database, and then reduce database costs that are associated with scalability. Thank you very much. I don't know if anyone has any question.
Thank you, Mr. Semeton, for the presentation.
Does anybody have a question?
Hello, can you hear me? Hello.
Hello.
Yeah, I can hear you.
Okay, the floor is open now for Semeton and Balogun. If you have any question for them,
hello,
you can throw at them.
I have a question for Balogun. So Balogun, you mentioned that SaaS is a cloud service. So but you didn't explain what's cloud? What's cloud?
Sorry?
What is cloud? Cloud.
You said what is cloud?
Yes, that the question is for it's for the first speaker, not you.
Okay. Oh, okay. So can I share my screen now?
Hello. So what was the question?
I said, what is cloud? Cloud. You mentioned that SaaS is a cloud service.
Yeah, I said cloud is like a form of. I was saying cloud is a form of computing whereby you can host your service on it, your softwares on it, and compared to doing it on a distributed network that can be quite limited, cloud computing can be accessible from anywhere. So it has become better to do and host services, your software services on it, because of how it delivers a much better range all over compared to just limiting it in a distributed network or a network that has some limits.
Okay.
Any more question for the two speakers?
Yeah, I have a question for Jide.
Okay.
All right.
I don't know whether you've said it or I didn't get it. Like, what's the full meaning of SaaS?
Software as a service.
Okay, software as a service. Okay, thank you.
You're welcome.
Any more question for the two speakers? If there's no question.
Good morning.
Okay, who is speaking?
I'm talking to the first speaker. This is Peter.
All right.
Sorry, sometimes the integration of, how does it work? Because you made mention of Uber and then using the SaaS. And sometimes we realize that it's not only SaaS they use, or there's other applications like IaaS also inclusive, or it's just SaaS alone. Some of these big companies that uses the wireless and this in services softwares now, is it just the SaaS alone, or there are other tools that we need to know about before we can venture into the SaaS?
Okay, so what I said was I was categorizing the likes of Uber under SaaS because of the method they use in executing that they deliver, which is the use of softwares. So yes, there are also other things that they use as well. They use different forms of APIs. They use different things all entirely together as well. So it's not just SaaS is just a method, a a kind of method enterprises and businesses going to now. You get whereby like Netflix now and the Dropbox, they all have softwares that deliver the service that they will provide, while there are also businesses and enterprises as well.
Okay.
So did
Thank
I
you.
answer your question?
I get. Thank you.
You're welcome.
Okay, Semeton, since there's no question, you can evaluate your audience. Balogun, you can prepare your own question as well to evaluate them. Just in 30 seconds. Semeton, over to you.
All right, thank you very much. I don't know. So you can tell me what database caching essentially means.
You can call a name if there's a optimal silence in the house. You can call a name.
Okay, all right. So Matimondi.
Did you call me?
I said that. Can you tell me what database caching is?
Yes, database caching is a way of saving some fragments of code in the main memory so as to retrieve very quickly.
Just to.
Okay. Should I say something?
I didn't get that.
Okay, I said it's like kind of saving some fragments, some little piece of code in the main memory so you can easily access instead of going to fetch all the way from the hard disks or something like that.
Oh, all right. Thank you very much.
So can I also say something about?
Thank you very much. Thank you very much, everybody. Mr. Peter, thank you for your contribution. The time is up. It's time for stand up for the respective teams. So the KD is going to come to an end now, but we should be time conscious. Thank you very much for the presenters. Thank you for the attendees. Thank you for your contribution. Thank you for your questions. Thank you for your comments. The KD is over. Thank you.
Hello, I have a question. No,
it's not entertaining any longer.
Can you hear me?
No question now. No question now, please.